All right, when solving trigonometric equations, I want you to stick to the basics, find the reference angle, identify the quadrants like we've been doing all along. And if you run into an angle that isn't related to a special angle, then you'll need to be willing to use an inverse trig function to help you find the reference angle. This particular equation, which is cosine squared x plus 3 cosine of x minus 2 equals 0, is one that we've seen its type before, that it mimics quadratic equation. And it's quadratic in cosine of x. Now, if you do a quick try of factoring, 30 seconds or less usually, and you're going to find out it doesn't work. Okay? Doesn't mean you don't have solutions, it just means that you need to use the quadratic formula. So if you use the quadratic formula, which you could do regardless, you would have your variable that your quadratic in is negative 3 plus or minus 3 squared minus 4 times a times c, all divided by twice a. We know that this really means cosine of x equals negative 3 plus or minus the square root of 9 plus 8, all divided by 2. And moving this up here, we know that this means that the cosine of x is either negative 3 minus root 17 over 2, or it's negative 3 plus root 17 over 2. Now pull out your calculator and let's get a decimal approximation that for now we're going to choose not to round, and let's see what happens. Alright, so observe the values that I found with my calculator. That negative 3 minus root 17 over 2 is approximately negative 3.56. I've kept all my decimal places. And negative 3 plus root 17 over 2 is roughly 0.056, keeping all my decimal places for now. One thing I do notice is that cosine cannot be a number smaller than negative 1, so the first equation will not have any solutions. And then the second equation will have solutions because cosine can be between negative 1 and positive 1. And your reference angle is the angle in quadrant 1 whose cosine value is the positive number. Now this number is already positive, okay? So there's no mystery here. But if it were negative, I would still consider the positive value to get my reference angle, because if it's positive and in the correct range of cosine and therefore domain of inverse cosine, then its inverse cosine value is the reference angle. Okay, so I have basically, let's backtrack here. I'm solving cosine of x is 0.561552813, and I get a reference angle that is arc cosine of 0.561552813. And then I know that cosine of x is positive in quadrants 1 and 4. So I know that I'm going to have a quadrant 1 solution that is the reference angle and a quadrant 4 solution that's 2 pi minus the reference. And you can take the values in your calculator after you get them and round them appropriately. So let's look at this. The quadrant 1 solution would be written as arc cosine of 0.561552813, and the quadrant 4 solution is 2 pi minus that. Now, to calculate these with correct decimals, then you're going to want to put your calculator in the proper trig mode. Squeezing that in there. And because this interval is in radians, you're going to put your calculator in radian mode when you deal with the inverse. Okay. And you're going to get decimals for me for these two guys. All right, let's pause and see what those will be. Okay, so here are my calculations. The first solution is 0.9745. The second solution, rounded to 4 decimal places, is 5.3087. Notice that I did not round anything until my final calculation, because if you round in the middle of the problem and then you round again at the end, you won't have accurate answers by the time you're finished. All right, so let's go back over this. This equation was quadratic in cosine. Since I did a quick check to try to factor it, saw that it wouldn't work in 30 seconds or less, I defaulted to the quadratic formula, which I could always use. We made a note that if a trig function could not be a certain value, then you can't solve the equation. And then secondly, if it can be the value, then you need to find the reference angle by using cosine equals the absolute value of whatever this number is right here. Okay. Therefore, you're guaranteed a quadrant 1 solution using arc cosine, and then you can go back and use our standard way of finding the other solutions using the reference angle.